Hey guys, thanks for coming. I just want to let you know that if you aren't able to make it today, this will be recorded and is going to go up on our YouTube. We're also doing a video presentation along with this, so if you see a little box in the corner of your screen with the G100, you can click that box and see what I'm doing with the video. But we're going to do a bit of a video install at the end, so stick with us. So we're going to get started. So right now we're just going to do a quick start walkthrough. This is going to be very general. It's going to focus more on our G100, but if you want to find more about the other quick start guides, that can be found either on our website or on our knowledge guide, or in our knowledge base on the website. We have quick start guides for each of the VFDs, and we found that to be a very big help. So this presentation is just going to be more of a walkthrough of that step by step. So as we get started, we're going to need to look actually at the motor rather than the VFD. So before starting the install, make sure you've got the motor parameters in front of you. I know I've talked to a lot of people over the phone that find themselves scrambling to find the motor nameplate information when they're right in front of the machine and they gotta keep going back and forth. So for your own sanity, I recommend having the motor nameplate information in front of you as you program the device, at least in the beginning. The picture below is just a quick representation of what's on the standard motor nameplate. There's a lot of stuff on here that we won't really be using, but you'll need stuff like horsepower and voltage and current and things like that. Horsepower and knowing the kilowatts is definitely very important. Now, this will vary job to job depending on the motor being used. None of this, the motor nameplate information will never be universal. What I'm telling you, what will be true for one will not ever be true for all. It varies job to job. As we move on to the hooking up the motor, make sure that the power is off. There are lethal voltage present, and that can be a very real danger. So you can either hook it up single phase or three phase. To hook it up single phase, you just connect the motor to the R and T terminals, and three phase is RST. And yeah, it's fairly simple from there. And yeah, quick startup with that. There are two basic kinds of keypads to work with. There's the LED and the LCD. This can be defined on the horsepower, the VFD series, and just the general keypad type. The LED is found on the G100 and smaller S100s, while the LCD is found on the IS7, H100, and large S100s. As you see, there are two very different ways of handling the keypad. One just arrows and has a much smaller screen that can sometimes make it a little harder to read. But there are ways of navigating that. The more user-friendly, admittedly, is the LCD on the IS7 and H100s. Those tell you quite a bit more information right up front, and tends to be better for troubleshooting and navigating, but those are found typically in bigger drives. So as you see, for the smaller drives, the LED keypad, you can navigate through using the up-down arrows. And that's what we're going to be using on the G100 here. As you can see in the video, that's going to be the same kind of keypad. So you can navigate using the up-down arrow to get through one type of parameter, but if you want to switch to the different parameters, you would hit mode. And to access other parameters, as I'll show you after. The main screen is going to be your command frequency, and you can access that using enter. From there, it's up, down, and mode. The next type of screen is found on the next type of screen is found on the larger drives, and that uses the LCD keypad, and much easier to navigate because it has 4 arrows. It's got left, right, up, down, and quite a bit more information on each. To access things like CNF mode or fault trip, you would hit mode multiple times. So if you get a fault and you want to see what the fault is, or dig into the fault more, you would hit mode during a fault trip, and it'll tell you what it is and the last couple of trips. If you want to reset it or find out about macros, you would hit mode again. Or again, if there's no fault, then you just do mode. But if there is a fault, it's mode. And that can take you into the parameters to reset it or check macros. Let's see. So now we're going to go into wire operation, command wiring. So, second, let's see if we can bring this down. Hopefully it's not blocking. There we go. I thought it might be blocking something. We're going to go into 2 and 3 wire control on the VFD. Now, 2-wire control is basically your standard. That's connecting P1 to CM and P2 to CM and just everything linked to common. That's also going to be your FX RX1 command. So P1 is forward, P2 is reverse. That's going to be the same on 3-wire control, except you're adding in P3 for stop. You're also going to have to enable parameter IN67 to 14 if you're using P3 at the stop button. It should be noted that 2-wire control is considered maintained and 3-wire control is momentary. So our VFDs allow the user to use analog inputs as well. This includes things like speed potentiometers and building automation controls and control wirings, like PLCs and things along those lines. The 0 to 10 volt DC can be connected via VR, V1, and CM, while the building automation or control wiring is connected via I2 and CM. On things like the H100, verify that the SW4 diff switch on the terminal board is I2 for the 4 to 20 milliamp signal. This is unique to each board, so make sure you pay attention to that. And for speed control on like a 4 to 20 milliamp signal, make sure you say DRV5 equals I2. So now we're going to get into the nitty gritty of actually setting it up, the parameters. So let's talk about the required parameters. These are the 4 essential parameters to make sure the drive runs properly. Wrong information could cause fault trips or damage equipment, and you don't want either of those. It makes it hard to work, and you don't want bad equipment. So to start, you go to the DR group, DR14, which is motor capacity. It's going to be in kilowatts or horsepower. We've got a conversion chart below to guide you through that. Keep in mind, this is dependent on each motor that you have, so it's going to be different for everyone. Up next, we're going to the basic parameters, BA11, which is the number of poles. That's based on RPM. You can find that on your motor nameplate information. And we've got a chart below that tells you RPM to pole chart. Just a general approximation, and we find that does come in quite a bit of handy. Let's see. Up next, we've got motor rated current at BA13 and motor rated voltage at BA15. Make sure that's correct. The wrong input on that could definitely damage the drive if it's, there's too much load on the system. All right, now that the required parameters are in, we're going to make sure we get the drive running. These parameters are created to make sure that the drive actually starts and stops correctly. So putting the wrong parameter in this could cause a lot of confusion, but it does happen. So in order to start a machine, you're going to need a run command, a frequency, and a frequency target. The drive will not move. So on things like the G100, you can get the command frequency on the main screen. As you can actually see in the video next to me, it's currently set at 0 as well. That's the command frequency. So you change that by doing enter, by pressing enter, and then you can change that number from 0 to 60. It is possible to go higher than 60, but that's a change of parameter. Once you set that, do enter, enter. And then from there, we'll move on to acceleration time and deceleration time. Now, these are in seconds. Default is 20 seconds for acceleration time, and deceleration is 30 seconds. This will also be dependent on the job you have. Different jobs have different needs for a different acceleration time. I know pumps can be a little bit different than just a standard drive, and we've run into things like in agricultural places or irrigation or crushing mills. Everyone runs a little bit different depending on their needs. From there, we've got the run command. Now, this is essential. We run into this problem quite a bit. The default is FXRX1, and that's connected to P1 and CM. If P1 and CM aren't enabled, then FXRX1 won't run. And that's essential. So that's the default. But there's also the RS485 Modbus, and then the field bus for Ethernet as well as options. Or you could just use the keypad. That's used less often. Up next, we've got the frequency command, where the drive is getting its frequency source from. Default is the keypad, but it can also be used with a speed pot, an external speed pot, or an internal speed pot, or a currency, or the Ethernet, or another field bus card as well. There are a lot of different options, and it really varies from job to job. But pay attention to that, because if you don't know where to look and where the frequency is coming from, then you're not going to get anything and be confused on why it's not coming out. So make sure you know where you're getting your frequency from. And then last is input voltage. That's 170 to 480, and that will depend on the drive that you have. And that is actually it for our presentation. We're going to do a quick start on the G100 right now in the video. So if you want to pay attention to that, I'm going to walk you through doing that on the video. So click the box and I'll make it a little bit larger. So before we started, I reset this drive just for your reference. And let's get this going. So you start with the DR parameter, going to DR14. No, I'm not actually connected to a motor, so I'm going to leave this at whatever default it is. It's at 0.40. So that's just an example. And then from there, we're going to go up to the BA parameter. You notice that I'm hitting mode to change parameters. Going to BA11. And that is the number of poles that is currently set for 4 poles. And then BA13, which is the motor rated current. And BA15, which is the motor voltage. Now, right now, there's nothing in there, but that's just because this is a test. And then from here, we're going to hit mode a couple of times to get back to the main menu. And I'm going to start with a command frequency. So press enter, and then mode, mode, mode to shift decimal places, just to make it easier so you're not pressing 1 all the time. I'm going to set for 50 Hertz. And from there, we're going to go up to acceleration time at 20 seconds. I'm just going to change it to 10 for an example. Deceleration time, same thing. I'm going to change to 10 just to use this as an example. And then DRV, I'm going to keep this at DRV1, which is FXRX1. And then FRQ, I'm going to leave this at 0 for the keypad. And then we're going back to BA19. And this is the input voltage is currently set at 220, so I'm going to leave that there. And that is the install. So to test this, I'm going to turn on, we've got a couple switches here. I'm going to turn on P1. And let me get back to the frequency screen. And you see that's running at 50 hertz. So that is your basic quick install, and you'll notice that as I did it, it only took less than 5 minutes. Once you get all the parameters in front of you, it's a real quick install, and you'll be on your way.